What we're about to look at together pertains to realized volatility. In other words, distributions of volatility that have already taken place, that have already transpired. You pick the window that interests you. So let's just say you were interested in a 25-day window. And what I'm going to show you here is how we can use this table over here to feed this volatility reading. This volatility reading needs to be annualized. And just like interest rates or rates of returns tend to be annualized, so does volatility. We're going to work with the R code that we have to feed in the values here that we want. Now, first things first, if what you're looking at is a 25-day window, then we're going to want our realized volatility analysis over here to be 25 days. And let's just see how we would go about doing that with the tools that we have. So I am, setting back to where we were originally. We were looking at a 5-day window. And if I was in my return histogram code that I gave you, when I'm looking at a 5-day window, it spits out standard deviation 2.34%. And that's all well and good, but that is not annualized. So if I was, for instance, looking at a 25-day window, that was what was interesting to me, then up here in my R code, I would change from 5 over to 25. And because this volatility measure is not annualized, we're going to get something different. We're going to get 4.92. That's just what it happened to be for the period, the number of years I'm looking back, for the ticker that I'm looking, et cetera, et cetera. So what I'm going to do then, or what you would do, is say, okay, well, I'm now going to input that 4.92 up here. So we're going to say 4.92 on a 25-day look back. And what that gives me is an annualized figure of 15.62. By the way, volatility, curiously, does not scale with time. So 2 days are not twice as volatile as 1 day, or 5 days are not 5 times as volatile as 1 day. Volatility actually scales with the square root of time. So the square root of 4, for instance, is 2. So there is twice as much volatility in 4 days as there is in 1 day. That's kind of a math nerd note. Anyway, though, what we find is that we get a scaled annualized volatility of 15.62, and then you could go in and say, okay, well then I'm going to assume 15.62 as my volatility metric, and now you get these updated output values, which is pretty cool. And one last note, we ran QQ plots with you just to get a sense as to, why we might not want to rely on extreme events. If we're within, say, 2 standard deviations, reality matches theory pretty well, but once we get beyond 2 standard deviations, not so well, especially to the downside.